we did the sum and difference. That's just adding the individual functions. That was pretty straightforward, basically just collecting like terms. We did f times g of x, a little tiny solid dot tells you it's f times g of x. It's not a composite function where you're putting one into the other. That's if it's like an open floating circle, like a degree sign floating there, okay? The only thing we have left is division. And division gets interesting because you have a function in the denominator, which means you have variables in the denominator, and what number are you not allowed to divide by? 0, so we get domain restrictions, okay? So we're going to go to page, we'll do this one. So where are we here? Page 48, bottom of page 48. Again, we're not doing the graph stuff. Here we go. We're just going to go straight to D. To D here. So our f of x function is x squared plus x minus 6. Our g of x is x minus 2. Write and simplify an expression for f over g of x. Okay. So f over g of x is the same as f of x over g of x. Our f of x function is x squared plus x minus 6, I should say. And then we have x minus 2 in the denominator. Okay. As soon as you write it out, what is our domain restriction? What x values are we not allowed to have? If I put 0 in there, that's okay, right? Because if I put 0 in, that goes away, that goes away, that goes away. I get negative 6 over negative 2. That's fine. What you have to ask yourself, somebody said it, oh, no, just erasing everything, is what makes the denominator 0? Positive 2, right? So right away, over to the side, our domain restriction is x cannot equal negative 2. And then technically, you should write afterwards, I don't care if you do, XER, because then it can be any real number that is not 2. I said positive, I'm sorry, why did I say negative 2? Sorry, positive 2. I know how to do math. Sort of. Okay, then your best friend in this class, well, it's not really your best friend, it's like a close acquaintance, is factoring. Okay? You need to know how to factor. It's going to permeate this entire course. All right? So, factor the top. What multiplies to negative 6 and adds to 1? Silence. Which one's negative? So you get that. What disappears? Boom. Those factors cancel. So we're left with x plus 3. That is a simplified expression. Later on in this course, we're going to look at the graphs of these functions. These are called rational function graphs. And a factor that cancels, well, first of all, what type of line is x plus 3? Yeah, I don't know who said that. Linear. Because the degree is 1. So don't write this down. I'm not going to test you on this yet. This is later on in the course. But this graph is a linear line with a slope, or the y-intercept of 3, a slope of 1. So it looks like that, except we have a domain restriction because of the original, the way it was written originally. Okay? X cannot be 2. So at 2, wherever that is, again, this is not part of this unit. It'll be later on in the course. There's actually a hole in the graph. Okay? So later on in this course, we're going to learn about graphs that have little holes in them. Okay? And if you go on in math, you'll find graphs that have jumps in them and gaps. We're going to look at vertical asymptotes. Did you guys do vertical asymptotes grade 11? Graphs that look like this. Again, you're not going to see this yet. You ever seen anything like that? Oh, this is just a glimmer of the good times to come then, isn't it? Ooh. All right, so that's what that actually means. We actually don't care about it for right now. In this unit, on this test, all I want you to do is simplify it and give me the domain restriction. That's all you have to do. All right, second bit. F over g of negative 6. There's two ways to do this. You could go f of negative 6, g of negative 6, and get an answer. What would be the faster way to do it? There you go. If you've already simplified f over g of x to get a new function, just plug that into there. That's going to be way faster. So I would just go negative 6 plus 3 is negative 3. And just to show you that it does equal the same, if I did f of negative 6 and g of negative 6, if you do all that, you're going to get negative 3 as well. I'll let you do the math if you really want to. Okay. Is that okay? Going once, going twice? Questions? Yes, sorry.
If you look at D and you haven't done the D yet,
Yep.
would it be easier to do?
It depends on you. It's really your call. I would say it's probably still easier to do this because that's a pretty easy factor and it cancels. And the reality is, I'm going to ask you to do this first, okay? Because this is more valuable because then I can use this to solve any number, right? That's one specific answer, whereas this function will give me all the answers. So, okay, next page, please. Here we go. This is page 49. The next one. Yeah. 48 plus 1. All right. So, simplify where possible. Okay. So we're doing f over g for all these functions. So the first one, boom. F of x over g of x. So it's just 2x plus 5 over x plus 5. Okay. What's the domain restriction? X cannot equal negative 5. So your domain is x cannot equal negative 5. If you want, you can write XER because that means it can be any number other than negative 5. But if you don't write the XER, that doesn't matter to me. As long as you put x cannot equal negative 5. That's the key part here. Okay? All right. Can I simplify this? I know there's people out there that want to do this. Oh, those will cancel. Those will cancel. Don't do that. You cannot do that. All right? You cannot cancel terms. Anything that is separated by an addition sign, those are separate terms. You cannot cancel those 5s or those x's, okay? Because of these addition signs or subtraction sign. If it was this, so let me erase all that because that's wrong. If it looked like this, 2x, I'll just leave it like that. If it was just 2x over x, okay, then, or actually I can just do this, and there's a 5 there. If they were all being multiplied, then you can cancel all that stuff. But if it's an addition or subtraction sign, that means they're separate terms, you cannot, okay? So you actually cannot simplify this. That is simplified. Can't go any further. So it's just 2x plus 5 over x plus 5 with a domain restriction of x cannot equal negative 5. Is that okay? All right, B. F over g. So x squared minus 2x minus 35 over x minus 7. What's my domain restriction? X cannot equal 7. What do I do? Factor. What multiplies to negative 35 and adds to minus 2? Negative 7 and 5. Are you guys seeing a pattern here? Most of the time, one of the factors is going to be what the denominator is, right? Because everything in math 12 is rigged to work out. It is. All right, so what cancels? X minus 7s. So what am I left with? And that is your answer. Good? All right. F over G, last one. Well, it's actually not the last one, but x squared minus 5x plus 6. Okay, so it gives you that. Can I see any restrictions yet? Nope. So what do you got to do? This time we have to factor the bottom. What multiplies to 6 and adds to negative 5? Someone said it right. Negative 2, negative 3? So I got that. Now, what are my domain restrictions? 2 and 3. You've got multiple domain restrictions. If you had 3 sets of brackets, you'd have 3 restrictions. If you had 4 sets, you'd have 4. Okay? You can have an infinite number of restrictions. All right. What cancels? X minus 2. So, if you cancel everything in the numerator, what is left in the numerator? 1. Okay? The answer here is 1 over x minus 3. Where people will go wrong that I see quite often is they will write, well, everything cancels, so the answer is just x minus 3. It is not. Okay? Because x minus 3 is in the denominator, it stays in the denominator. So just remember, I could write the numerator like this with a 1 there. That's the exact same thing. Nobody does that because you don't have to write a 1. But you wrote it like that, and you can see, oh, it's 1 over x minus 3. Okay, so just be aware of that. That's a common mistake. All right, last question for the first unit of Math 12. 1 week, we did 1 unit. That's pretty good. All right, here we go. F over G. Oh, it's one of these weird ones with a little number in front. So, here we go. F over G. 2x squared, 13x minus 7 over 2x plus 1. What's your job right now? What's the first thing you do? Okay, what's the restriction? Ooh. If you don't know the restriction, just take the denominator and go, just like we did with the radical functions, 2x plus 1. What makes it 0? You move the 1 over, divide off the 2. That's your domain restriction, okay? So the domain restriction is x cannot equal negative 1/2. All right, you got 1 mark on the question. How are you going to get the rest? Factor it. Do you want to try it on your own? I'll give you 1 minute on your own, then I'll go over it. Drink my tea. All right. So first step. So I just took the top. I just took this, brought it over here. First number times last number, negative 14, right? What multiplies to negative 14 and adds to negative 13? Negative 14 and 1. Everybody good with that? Break up the middle term into negative 14x plus x. So that's the negative 14 and the 1 there. What do I do from there? I can zoom in if you want. What do I do now? Bracket the first two. And take out a common factor. What's a common factor of 2x squared minus 14x? 2x comes out. Leaving with x minus 7. What do I do now? Okay. But I should factor something out of there. A 1. Yeah. Right? Because those, if I take a 1 out of that, it doesn't change anything, right? That's the exact same thing. I mean, you don't, if you remember not to do that and then you fill it in at the end, that's fine. But how do you know you're doing it right? What's a big clue that you're doing it right? Yes, these are the same. If they're different, then this has gone sideways somehow. Okay? And so the next step, what you technically do is these are your common factors, and you pull those out, and you'll have to 2x plus 1 and an x minus 7. That's technically what you're doing, but what everybody usually remembers is they just go, oh, the two brackets become 1, and then I just have a 2x plus 1 there. And that's the factored form. And if you do it a different way, that's fine. I don't care how you factor. You just need to know a way to factor, because it shows up forever in this course and any other math course you're going to take. All right, so that's my factored form. So I put that back. I'll do it right below. So the top becomes x minus 7, 2x plus 1 over 2x plus 1. What disappears? 2x plus 1s. And you're left with x minus 7. So if I said, what is f over g of 3? What's the super easy way to do it? Just put it right there. So I'd get 3 minus 7. That's a really bad 3. Negative 4. Okay? Basically just factor and cancel. Whatever makes the denominator 0 is your domain restriction. And simplify. That's it. All I want you to do is 5D and E. And then we're basically done. Tomorrow will be a review block.